map. That's fine. So we could map the list to each number incremented by one. And then we could filter it by saying, okay, we only want the numbers such that modulus 2 is equal to 0, or the even numbers of the list, right? So does anyone know what the value of special list would be? What numbers would it hold? Yeah. Let's check. Yeah, so one, I kind of like see where you're getting with that, where it's like we're only gonna have one value left. But the thing is, so map is going to basically like increment each of these values by one. So after map, map is going to return a copy of my list with the values 2, 3, 5, 7, 9, 11, right? So after map, we have that copy of the list with each value incremented by one. And then we filter that copy by checking for even numbers. So this filter makes it so there's no evens left. And I mean, sorry, it makes it so only the evens are left, right? And after we increment each number in the list, the only even left is actually it was originally one, but we incremented it to two. So that's why two is there. Does that make sense? Um, No, so the way that it works is my when we say specialist equals my list, right? This might look like a single line of code, but actually it's just like because of the spacing, like I didn't want this line to go too long. So what this is really saying is specialist is equal to my list dot map. And when we call dot map, it returns a copy of my list. And it returns a copy of my list with each element incremented. And then dot filter basically returns a copy of the mapped list, but with only the even elements. Does that make sense? Okay. Does anyone else have any questions on this example? Yeah.
Data types of this, so then what would happen if you have, say, like map or filter applied to values besides an order?
Yeah, that's a good question. So, just so like quick, I'll go back to a previous lecture for a little bit, which is I did mention that Kotlin is a statically typed language, which means that all types are known at compile time. Like a simpler way of saying that is like before we run the code, we know all of our types. Like we have all the information about our types. So let's say that list of I could take a one, I could do like one, two, and then I put like hello world, right? What would happen? So the thing is, you'd actually get a compile time error. Like there would be a red squiggly under it, and what it would say is that like you can't have a list that has mixed types. And the reason for that again is because Kotlin is like all the types are known at compile time. So this list of is actually a function with a parameterized type, which basically just means that like we can we like the we can use list of for different types, but it like in this case it creates a list of integers. And it's able to do that because we only pass in integers here. Does that make sense? Okay, cool. Any other questions? Okay, yeah, really good questions there. Yeah. So, and then we have like another just very useful higher order function, which is for each. So this one will basically just call whatever function you pass in on each element of the list. So this one just prints each element. And yeah, this shouldn't be like comparing it to the other ones, it shouldn't be too hard to understand, but it's basically just allows you to just like iterate through each element. So yeah. And then we also have for each indexed. So sometimes you want to perform an element on, or sorry, sometimes you want to perform an action on each list element, but you still want to have access to the index, like for whatever reason. So there's also like an individual extension function, or sorry, a higher order function for that, which is right here. So yeah. Just to summarize the section, so we can pass functions as arguments to other functions. And the it keyword is the implicit function parameter. So whenever our function only has one parameter, like right here, we can use the it keyword next to it. But when our function has multiple parameters, we actually have to use this syntax and name each parameter to be able to access it. So we know which one we're going to access. So here we name the first parameter index and the second parameter item. And this is the function that we're passing in for each index. And then you use this little arrow here. That's actually a dash and then a greater than sign. And that allows you to, that's just the syntax that you use to name the parameters. So yeah. Yeah, and methods like filter and map are just like super useful in Android development. You usually do a lot of like data processing in Android and like packaging data neatly and stuff like that. So something that's like these extension functions are really important to be able to do those operations concisely. Cool. Okay. So now we're going to get into the next topic, which is extension functions. So extension functions allow you to add functions to a class that you might not be able to modify. It just makes code a lot more reusable, and it is essential knowledge for Jetpack Compose development because you're going to be using it and like creating extension functions basically all the time. So yeah, let's see some examples, and we've actually already seen some. So what I'm going to do is define an extension function on the string class. So the way that you define an extension function, the syntax takes a bit of getting used to. I had to look this up for like the first month or so when I was like learned extension functions. I had to keep looking this up. But basically what you do is you write fun, and then you write the name of the class that you want to add an extension function to, and then you add the extension function. So it starts with K. And here's the return type is just Boolean. And then you'll see that we use the keyword this. So if you've worked with Java before, you know that whenever you're inside of a class, you can use this to reference like the instance of the class, the current instance, or like the current instance of the class. So we're checking if this string starts with the prefix K. Um, yeah. And like the cool thing about this is like you get access to a lot of the methods that you have inside of a class. And the other nice thing is that I could call dot starts with K on any string. So if I put like in quotes, hello world, then I could do after that, I could do dot starts with K. And that would work because we basically just like added a new function to the string class, just like how split is a function on the string class or trim is a function, right? Now starts with K is a function that we can use. Yeah, so that's the first example. And then this one is like a bit more complicated, but this is a real extension function that the Kotlin library has implemented. And this one is null or empty. So this is really handy. Like if you have a list that basically it could be null, right? It could also be empty, but let's say that we only want to do something on this list if it actually has elements in it. And this is a really handy way of doing that without having to write out this statement every time. So what we do is we first just check, okay, if this is null, then we can just return true, right? Because we know the list is either null or empty. And then otherwise, we can just return this dot empty, dot is empty. Uh, yeah, so now it's like this is pretty similar to how the Kotlin like standard library actually implements it. And it's just a very convenient thing that you can do on a list that you don't know if it has items, you don't even know if it's null or not, and you can call this function. Yeah, any questions on extension functions so far? Yeah. Yeah, good question. So this is another Kotlin concept that I referenced earlier a little bit, which is the parameterized type. So basically the idea is that I want to be able to check if any list is null or empty, not just a list of ints or not just a list of strings. I want to be able to check if any list is null or empty. And the way that I can do that is basically just by saying that this function operates on some list of type T. We don't know what type T is. Like it could be int, it could be string, but it just operates on some list of type T. And that's just, this is like the syntax that you use to specify it. So this is another syntax that definitely takes some getting used to, but you just put like the type parameters first, and then you put the class that you're operating on. And another thing you'll notice that I didn't explicitly go over is this like question mark here. And that is basically just like shows that this list is a nullable type. So like this list could be null. That's the class that we're operating on. Any other questions? Okay, cool. Okay, so now something really cool is that we get to look at the inside of how the filter function is actually implemented, right? Because filter is an extension function on some list of type T, right? We're specifying this type T, and it's a filter function on like one of these lists. And the cool thing is, like you can see now, here's how we pass in a function as a parameter. So we say, okay, we're passing in a parameter called predicate, and this parameter has this type. So it has the type T arrow Boolean. So like let's say T was an integer, right? We would have a list of ints. So we'd want our predicate function to tell us if each int is in the list. So we'd want it to take an int and return true or false based on whether each int should be in the list. So yeah, this T could basically take on any type, and we're saying we want the predicate to take values that are in the list and give us back true or false. So yeah, and then here's an example of like how this might be implemented. So we have a result, which is just an empty mutable list of T, which is the type of the list. And then we go through the list and we say, okay, if it passes the predicate, so predicate of T returns true or false. So if it passes the predicate, then we add it to our result and we return the result. So now you're getting to see like how the internals of these Kotlin functions are actually implemented. And I feel like having an understanding of this can allow you to kind of write your own convenience functions like this and just make your code much more concise. So yeah, any questions on this? I know we're introducing a lot of syntax here.
Or is it like the predicate between lists?
Oh yeah, good question. So what's doing the looping through the list here is this for each. So we call dot for each on the list, and we're going to pass in the behavior that we want to do on each list element, right? And maybe the internals of for each, it might look something like this. So you might have like list dot for each, and then inside of here, we might have like an object-oriented for loop that kind of like calls the function that we pass into for each on each element. So yeah, for each is doing this iteration. And then on each element of the list, we call the predicate function to see does it pass or does it fail? And if it passes, we add it to the list. Did that answer your question?
Just to say that.
Oh wait, do you mean up here? Yeah. So that's when, like, whenever we specify a function, we have to specify the parameters of the function. So if we had, like, if this was just sum, right? In those parentheses up top, we'd put like a colon int, comma b colon int. Like those would be our parameters. But here, our parameter is actually a function. So our parameter is called predicate, right? That's what we pass in every time we use filter. And then the type of predicate is, okay, we want to take an element of our list, T, and we want to return true or false. So that should be the type of that function. Does that make more sense? Okay, cool. Any other questions? Okay. And then here's an example of an extension functions in Jetpack Compose. So modifier is a class in Jetpack Compose that Mihili is going to be going over in her lectures, but it basically allows you to style different components. And all of these, like offset, padding, scale, these are all implemented as extension functions on modifiers. And you can actually implement your own extension functions on modifiers as well to do something like the shimmer effect. So this is like a super popular design pattern in apps where when you have a screen that's not fully loaded yet, you show like a little shimmering animation. And this is actually how you would implement this in Jetpack Compose. So don't worry about like the how it's actually implemented because we haven't really gotten to a lot of the UI stuff yet. But the point is that if you implement this as an extension function on modifier, that's just really powerful because now whenever you have a component and you want to add a style to it, you can always like reference this style. And it's as if it was a modifier that Android made for you. So yeah, this concept is just like super useful. Um, yeah, so that's that. We can add functions to classes that like usually we can't modify, right? Like we're not going to go into the standard library and add a function to the string class, but we can add convenience functions through extension functions. and it is an important concept for composed development. And there's also a bunch of extension functions provided for us that make writing Kotlin way more concise, such as map and filter, which are probably the two most useful ones that you'll end up using. Cool. Okay, so I have a little exercise here. What you can do is open up Android Studio, and you can create a function. You can put fun main and then squiggly brackets. So I can actually do it as well to demo. But yeah, and you can try out this exercise and see if you're able to do it. So let me see if I can. So this is a cool trick that you can do. Let's see if I can zoom in. Okay, there we go. So a cool trick you can do in Android Studio is if you type fun main like this, right? So you just declare a function called main with no arguments. You get this little play button on the side. And you can press that and it will run whatever Kotlin code you have. So yeah, that's like a nice, I'll try to see if I can put this like on the side. Yeah, you can reference it here and then try to see if you can figure this out. So might be a bit hard to see, but basically you want to write a function called only evens that just returns all the even numbers in the list. And it should be an extension function on the list of int class. Let me see if I can see. Wait, I can't see from here.
Collapse the side.
Oh, how do you do that?
Oh, it's like,
Do you want to do it? Oh,
okay.
great. Okay, teamwork. Yeah. And feel free to look up the syntax for extension functions. As I said, it's pretty hard. I would not expect anyone to have it memorized by now. But yeah, so just try this out. We'll do a few minutes for this. Oh. Okay. Wait, we have till 9:25, right?
Yeah.
Okay. Yeah. Okay, so we'll just do like a few minutes. Don't worry if you can't get it done in time. But it's good to just like try a little bit on your own. So yeah, and then I'll show the solution. I don't know if we'll have time to go through all the examples, but it could be good to go through them on your own because we still want to get to like the last topic. We could definitely come back to these if we have more time. Oops. Okay, so yeah, I know I didn't give too much time, so don't worry if you weren't able to get it done, but it's good to have like a little bit of time to just try on your own. All right, so now I'm just going to make the function. So we want a function on the class list of integer, and we're gonna call it dot only evens. And now we have, this is like the header for our extension function. And now we want to define the behavior. So there's, I mean, was anyone able to finish and like want to talk about what an implementation might look like?
don't think it works. But I tried doing like this dot filter and then a mod 2 equals to 0. I think I got some syntax filters.
Yeah, okay, that's actually a really good idea. So using filter can make this a lot more concise. And what we can do is say, okay, so we want to filter the list for it mod 2 is equal to 0, right? Let me full screen this so we can see it better. Okay, but then the other thing is that this is supposed to return a Boolean, right? So we need to specify the return value. But then once we do, we'll see that, okay, we should have an error here. Oh yeah, it is down there.
Oh, we go.
Yeah, so yeah, we were supposed to return true if the list has all evens. Otherwise return false. So we use this dot filter, but then we see we have like a little error down here. Yeah. Yes. So this dot all, that's a very like kind of a sneaky way of doing it because we already have this defined for us. So all is an extension function that takes in a list. It's an extension function on the list class, and it returns true if all of the elements of the list pass the predicate that we pass in, and returns false otherwise. So this is like pretty much the ideal solution. But if you don't know about the extension function all in advance, this would be pretty hard to spot. So I wanted to show another solution that uses filter. But yeah, this is basically like the most concise, like the ideal way of doing this is just to actually use an extension function that's already defined for us, which just says, okay, return true if all of the elements pass this predicate and false otherwise. Before I show like the filter version, does anyone have questions on this version? Okay, and now let's go over the filter. So this is actually going to be pretty similar. So we can filter out our elements. We can filter for our even elements, right? But this returns a list, and we actually want this to be a Boolean. So what we can do is actually compare it with the size of the list, which is kind of cool. Like it might not be something that you would expect to do originally. Let's see what's happening here. Oh, right, sorry, dot size. Yeah. Okay, cool. So that might not be something that you would like think of doing initially, but it's kind of like a cool way of implementing this, and this might be how the dot all function is implemented, where we first filter for the predicate, and then we just say, okay, if the size of the filtered list is the same as the size of our new list, then that just means that all of our values pass the predicate. So yeah, using dot filter is like really good intuition here. But of course, like I guess the ideal solution is to use dot all if you're aware of that. But yeah, does this solution make sense for everyone? Okay, seeing some nods. Cool. Okay, let's go back to this. So I think we're gonna come back to these at the end because I want to make sure I have time to get through. Okay, great. So we're back and I'm going to, oh no. Yeah, so wait, what happened? Okay, wait, this is so sad. Okay, so Um, yeah. Basically, I'm not happy with this code. Okay. Um, so I'm not happy with this code because it does not have the nice guarantees that the Kotlin programming language will allow. And I'm gonna like reveal some of this code that we don't know about. And maybe it'll give you some ideas of what could go wrong here. So what we're doing here is we have this global scope dot launch. So this is pretty advanced, but I'll try to explain it in a simple way. And this is why I didn't really expect people to see this. So global scope dot launch, what this does is it runs this code, but it runs the code in the background. So our program, when we do global scope dot launch, like our program will immediately go to this next line if test is not equal to null, right? So what happens is we initialize tests, we launch this, but this happens in the background. So we launch this and there's a delay of 1 second. And it's happening in the background. So we still go to this line. Let me turn on the laser pointer because that's kind of cool. I don't know. Wait, where is it? Okay. Yeah. So we still go to this line right here. Okay. And right now, test is not null. So we go inside this if statement and we wait 2 seconds. But remember, this code is running in the background. So after we're waiting 2 seconds, and while we're waiting 2 seconds, our 1 second has passed. And we set test equal to null, right? But then remember, this just happens in the background. So our program is still here. Our program is still waiting. And then it finishes waiting and it tries to print the length of test. But what happens here is that test is null. So yeah, that's like a bit about concurrency, which you're going to learn more in depth like later in the course. But this kind of motivates how we want to deal with null values, which is like through the use of higher order functions and extension functions. So yeah, this is definitely getting a bit more complicated, but just the key idea here is that this code runs in the background. So it's kind of like creating another process that's running in the background. And it's running this code. And then like this if test is not equal null executes immediately after test equal pretty much immediately after test equals hello world, right? So this would end up being true. And then we go into this code block and wait, and then we would try to print a length of something that's null. So yeah, I know it's like a bit more complicated. Does anyone have questions on that? Okay, cool. So our solution to this is .let. So this is an extension function on any like nullable type. And what it does is actually all it does is it just calls whatever block we pass in here with the value of test as the parameter. So let's try to go through and figure out like why does this code not have the same issue as before? So we start with test equals hello world, and we delay 2 seconds. And up here at the same time, we delayed 1 second and we set, oh, okay, that should say test equals null. Yeah, we set test to null. Sorry about that. We set test to null. And then here, the thing about question mark dot is a special way of interfacing with optional values. So what happens with question mark dot is it will only call the function on the value if the value is non-null, right? But the thing is, we already waited 2 seconds here, and test is null. So dot let won't even be called, right? And if you reverse the order of these, then what would happen is, right? Like you might be kind of tempted to maybe say, okay, well, what would happen if I immediately executed test.let and then I put a delay inside of test.let, right? Then you would be like, oh, well, when the value of test have changed. So I still approve of this code, and I will show you why. So yeah, we already talked about this, but the interesting thing is that the value of test is captured in the function. So what does that mean? Remember that we're specifying a behavior, right? So it is actually not the same thing as test. This definitely gets a bit confusing, but what's happening here is that even if we did like somehow put a delay in here, right? When we call .let, what it does is it takes the current value of test. So in this case, right, if we didn't have this delay and we had it inside of here instead, what would happen is we would execute this function and we would pass in hello world as the parameter to that function. So we'd actually pass in a copy of test into that function, right? And that's what it actually holds. So it holds a copy of the value of test when .let was called. And because it holds this copy, we actually have that the value of test is captured in the function. So this current value of it, you can see even actually its type is string, not string question mark, it's string. And the reason for that is because we only call .let if test is non-null. And this is basically how you should always be handling optional values in this course. It can be really tempting to write like if variable does not equal null, then we want to do something, right? But .let is like almost always going to be a better approach. So yeah, and just yeah, and if you want to see like the implementation here, right? this gets a bit more complicated. Don't worry about the contract or inline, but this is the actual implementation that the Kotlin standard library uses. So we can see it takes two type parameters. So the type of the value that could be null, right? So we have this like t, and then we also have r, which is the return type of dot let. And we pass in as a parameter, right? We want to operate, we want to perform some operation on this value and return some type. Like we don't know what that type is going to be, right? Like here, we're actually just returning the unit type, which just means we don't return anything, and that's totally fine. But yeah, so we call a block, we basically just return block of this. So what that means is like if this was let's say we have like tests here, right? When we pass a string to a function, that will get copied when we pass that in, right? We're actually passing the value of the string. We're not really passing like a reference to the string. We're just passing the value. So hello world. And then it will operate on that value. So yeah, that's a pretty complicated example. Just like for some more intuition, and then I'll have time for questions. Like instead of checking if something is non-null, right, and then doing something, we're basically saying, here's what we're gonna do with this value if it's not null. So we're specifying a behavior, right? Yeah, so yeah, we're specifying the behavior. That's the key idea. Instead of just like checking if something's not null and then doing something as a separate operation, we're saying, okay, here's what we want to do. Like if this value is not null, here's the behavior we're going to perform on this value, right? Okay, so now I want to open for any questions on .let. It's pretty complicated stuff, so I was expecting some questions, but I guess maybe I did a good job. Yeah, okay. Here's another example of like more advanced null handling using .let. So we have our variable string, right? Which again, you kind of just want to avoid using variables, but we just have it here for the sake of example. So and then we want to get a string, we want to create a string called readable length. So maybe you want to print out the length of the string. And we say, okay, test question mark. So if it exists, here's the behavior that we want to do on this value. So the behavior here is going to basically return this string. And this string just shows the length of the string, right? And yeah, so we're passing in a function that returns this. And this is like another bit of Kotlin syntax, which is that if you put a value as the last line of a function, it will automatically get returned. So we return the string, and yeah, I guess we are at time. But yeah, we're like very nearly done. So we return the string, and then this question mark colon says if the left-hand side is null, then we want to give it this value, right? Because we specified that readable length should be a non-nullable string. So yeah. Let me think if there's anything else I have to explain. Yeah, I think that should make sense. Any questions on that? Yeah, yeah. So Colin will, because we're using tests right here, and then we have question mark dot let, like Colin knows that we're gonna call it on this test variable. And if we look back at like, oh yeah. So this is the parameter of the function. So if I go back to here, right? We basically called block, like so we called this block of code here. And we called that on the value of test, which in this case was test. So yeah, we basically call it's like this. So this would be equivalent if I go back to Android Studio, right? Let me see if I can write this out. Uh, so I'll just say like length, and we'll take in a string. string, and we'll return, let's just say length is a dot length, right? And this is just telling me I need to put the type here. Okay, so now this is basically like this let statement here, where we say, okay, we call dot let on test, right? This is like basically just saying that if test is not null, we would call length of test. So we're passing in the value of tests in as like a parameter in this function. So that's really all this is doing. So this like these curly braces behind the scenes is actually like just basically like a function like that. Oh yeah, okay. So question mark colon, that's actually not calling it the second time. So what that's doing is basically the thing that question mark dot does is it says, okay, so if test is null, if test is null, then this expression will be null. Like we're not even going to get a chance to call this function, right? Because it wouldn't make sense to call dot let on a value that's null. Like we can't pass in any value to our function. So yeah, we use question mark dot there, and then we evaluate this, and this whole thing will either be evaluated to null or it'll be evaluated to the string. And then we use question mark colon at the end to basically say, okay, so if test was null, then we want this expression to evaluate to the length of the string is unknown. Yeah, because if test is null, then this function won't even be called, right? This question mark dot says if test is null, we'll just immediately return null. And then this whole thing would just be null. But yeah, question mark colon returns that right-hand side. Any other questions? I know I think we're 5 minutes over time. Unfortunately. 4 minutes, yeah. Okay. Okay, cool. Yeah. If anyone has any questions, feel free to come up to the front as well. But that's going to be it. I also did have some extra slides in there. I knew this lecture was dense, so we might not get over all of it, but it's not super essential. Like basically it just shows you how to use Kotlin to like make your code more concise. So you can look at this if you want. It's pretty optional. Yeah. Also, Kotlin's cool. Yay. That's the lecture. Thanks for coming, everyone.
Oh, if you didn't get to join the Kahoot, come up to us now and give us your net ID so we can like mark you down as present.